All right, we're going to get started for our ASME Python Jumpstart. Can you guys just raise your hands just so I can kind of identify you if you're here for ASME Python? Yeah, cool, awesome, thanks guys. Now just out of curiosity, how many of you guys have any coding experience whatsoever? MATLAB, C++, anything? Everybody here, okay, awesome. So this is going to go great then. And just to kind of start off, give you guys an overview, Clarkson does now offer a little certification through their badges, which if you're not familiar with the badges, Clarkson has a bunch of these different kind of skill sets that you can go on Moodle. You can sign up for their kind of like courses and their classes. And you can basically just get a little certification that you can have in your resume that basically says that you are certified up to some skill set for that skill. And for Python, there's a bunch of video series there with lectures and quizzes and problems for you to go through and really get deep on a lot of the stuff that we won't be able to cover just due to time constraints. So if you really want to have an overarching understanding of all of the stuff that's going on in there, I highly recommend the badge course. You can go onto the Moodle. We'll send out this slide deck afterwards. The link is embedded in there, and you can just sign up for that, and it'll automatically add that Moodle page to your Moodle site. And you can work through your lectures at whatever pace you see comfortable. But if you don't feel that you have time for all of those lectures and going through all that stuff, this course is going to be designed to basically just give you all of the tools, really densely pack all of the things that you need to just get started with coding and with Python, to have those all on this slide deck for you so that you can just get moving with it. And then anything else, you know, there's Stack Exchange and Google, and obviously tons of resources out there for learning Python. And if you ever have any questions about functions or things like that, there's just so many resources out there. It's very easy once you get started to just kind of go, I want to look for how to do this thing. And Stack Exchange will tell you 100 ways to do it. So without further ado, a little overview of the entire course that we're going to do. We're doing 3 sessions of this. So this is going to be the first session, which we're just going to be really lecturing, I guess. We're going to go through how you're going to install Python, get it using on the school computers, and then just hard coding some very simple variables, slicing through stuff, if statements, loops, those kinds of things that are going to form the basics of how we code everything in Python. And then in the further sessions, we're going to get a little bit more into some functions, maybe having multiple scripts working together, and then some of the modules and libraries that Python has, both built in and external. There's a lot of things out there for like working with Excel, which is one example that we're going to get into because that's very important for engineers, right? We have lots of data that we need to look through, and you're not going to go in and code every single value into your script. So you want to be able to load in an Excel file or a CSV or something like that, and just have all of that data in there for you to manipulate. So that's kind of the overall course picture that we're going to look at. So again, just what we're going through here tonight is right there. Starting with installation, if any of you guys have personal computers with you, you can just go to python.org and you can click download. There's a separate thing for Mac that's specifically for how you're going to add that stuff. If you're on a Windows machine, if you're on one of the school computers, which it looks like all of you guys are, you can just go to apps anywhere. And then close to the top of the page, you'll see Anaconda. You're going to want to open that. Anaconda is going to automatically give you some prompts and everything, but it's also going to open up a window that's going to give you a bunch of other options for different interfaces that you can use to make your scripts. I'm going to recommend that you guys start with Spider. So when you open Anaconda, you should see Spider as one of the options on the bottom row. Jupyter is what they use for the badge course. And so that looks a little bit different. But Spider is honestly just what I'm more comfortable with. And I think it's pretty easy for us to just kind of get writing some small scripts with. So if you guys want to follow along and just have Spider open, I'll have a bunch of example codes up on the slides, and you guys can just kind of copy those down into Spider, play around with them while we go through, and you can just kind of follow along and see how things work. Any questions? Has everyone been able to open Spider? Yeah.
So I actually am using my laptop. Is this going to work with PyCharm as well?
Yeah, PyCharm works perfectly as well too. So yeah, let's actually get into that. So Python, right, itself, when you download it, what you're really getting is the interpreter, which is taking everything that you're writing in a script and turning it into an executable for the computer to understand. So when you write a single line in Python, that's a single line, obviously, of kind of gibberish to the computer. It's something that makes sense to us, but we need something to transfer that into an executable. So that's what your interpreter does. But then you have something called your IDE, which is your integrated development environment. That would be PyCharm, Spider, Jupyter, or any of these other ones. There's a lot of different ones. People have their own kind of personal likes and everything. There's not really so much one that is better than another, but you can see Jupyter on the bottom left, which is what, again, they use in the badge course. PyCharm on the top right. Personally, I found PyCharm is nice for working with projects. It'll automatically sort kind of your files. They're going to go together so that they can read off of each other. Spider I like for just writing a short, quick little script because it'll allow me to place my files a little bit easier. And then another thing about Spider is in the top right of that screenshot, you can see a little variable explorer. So if you're looking at, again, a CSV file with 100 rows and 100 columns, you can actually go in and see through the IDE what that basically looks like almost in a little table. Okay. So variables obviously very important. That's how we're going to be working with a lot of the stuff because we want things to change. That's how we're going to make the computer do things efficiently for us, is we're going to have things changing throughout time. So variables are nice in Python. They can have pretty much any name as long as it starts with a character and does not look like any of the ones in the table there. Those are keywords that are saved for Python actions, functions, and things like that. So if any variable that you try and make looks like that, Python's going to read it as a specific function, for instance, the false Boolean. So it's going to read it as a value rather than a variable that you're going to give some value to. Okay, so what we're going to assign our variable types can range to. So Python is also nice because unlike some coding languages, I could assign a variable X to be a string, right, which is a combination of letters, characters, and then in the next line, I could assign that same variable to be an integer or a range or another data type. So its variables can be reassigned based on any data type. But strings, which you can see are going to be enclosed by either a single quote or a double quotation mark. If it reads a second beginning of the quotation mark, so for instance, in there that it's raining, it sees that second apostrophe, which is what it started the string with. So it recognizes that as an end of the string. So the S space raining doesn't make any sense to it. So it sees that as a syntax error. The way you would get around that is by using that backslash character. That's going to basically tell Python that whatever the next character is in this string, it's something different. So it's not what you usually see it as. So it sees that, then it sees the apostrophe and it goes, oh, okay, that's going to be included in the string then. And then just another one I included there is the backslash n, just because it's one that I find myself commonly using. And that's just the character for a new line. So basically hitting enter on a keyboard. Integers, floats, complex. So you have numbers, right, which are identified by just saying int parenthesis the value, or float parentheses value. And then complex, you could either do the same thing with 2 values, or you could just do 3 + 4j, something like that. It uses j rather than I, but we all know it's the imaginary number. And then ranges are kind of an iterable. So we're going to get more into ranges later. But with that statement right there, you can see it's a range starting at 0, ending at 10 with an iterable of 1. So it's going to count by ones from 0 to 10. And something that's important to remember with a range function is that that range does not actually include the value 10. It goes from 0 to 10, but does not include 10. So it will count 0, 1, 2, 3 up to 9. Okay, slicing, very important for once we have a variable, we've established it, and maybe I only want a part of it. So another variable type is going to be our lists. Lists can store multiple different values inside of a single variable. So in this case, the first list you see there, my list, is just the numbers 0 through 5, or the integers 0 through 5. In that case, each value within that list is the same data type. Doesn't always have to be like that. And then you can also see a same way of saying that would be my list range 6, because that range is, again, going to give you that 0, 1, 2, 3, 4, 5, again, not including 6. And the reason I also showed that to you is that that is a default expression. Right before we saw range as having beginning, end, and the amount that it's counting by. If you do just one number, it's going to assume you're starting at 0 and that you're counting by ones. It is not going to, and it will also assume if you just put in two numbers, that the first one is where you want to start, the second one is where you want to end, and what it's missing is a default one that it's going to count by ones. So if that's something you need to specify, you need to put in all three numbers. It will always assume that the first number you put in when there's just two digits is the starting and then the ending. And if it's just one value that you put in there, it's always going to assume you're starting at 0 and counting to that number by 1. Slicing, which you guys should understand a little bit about from MATLAB, works very similarly. So if I want to call a specific value from that list, unlike MATLAB, our indexing starts at 0. So the first element of a list is going to be indexed at 0. So from our list above, my list of the 0 through 5, the index of 1 is actually the second element in that list. So when I enter that, what it's going to return to me is 1. If I put in -1, that's actually going to ask Python to grab the last value in that list. So that's going to give me a 5. And then a -2, you can continue with this pattern. It's going to count backwards from the end of the list. So that's going to give me the second to last element of that list, which is going to be 4. And then again, slicing between different values is done with a colon. So the first value being the first index of what you want, and the last value being the last index of what you want. And colon is saying that I'm going to select all of the things through it. And then I can also abbreviate that if I want to go all the way through the end, but I want to start at the third element. I'm going to say my list 3 : and that's going to tell Python start with the third index and then get everything from the list after that. Any questions from this part? How are we doing on speed? You guys need me to go slower, faster? Little slower. Okay, cool. So typically in MATLAB, when we were dealing with multi-dimensional things, we would call them arrays or matrices. In order to get those in Python, we actually need to import another library, which we'll get to later. But instead, we can have nested lists, right? So I said that a list can contain different variable types. That includes another list. So for instance here, I have 3 lists, which are each 2 values of strings. It's a first name and a last name. And then I can create a list of these 3 lists. Now, when I call for an item in that list, I need to bracket for the first index to say that I want the second item in the main list, cool kids. And then I want second index, third item, really, right? And I want the second item within that smaller list, which is going to be the ending item, which is going to be Knox. Does everyone see how that works? So let's see if I can find my mouse here. We have our full list, which is all of them put together. I'm going to index the first one that I want, which is going to be name 3, right? Index 0, 1, and 2. I'm going to get this value, and then it's going to be pulling the first index from that. So 0, 1, and that gives me Knox. And then another thing to note is that because these aren't matrices, they don't need to all have the same dimensions. I could have a list of lists that are different lengths. So here's a long list, which is all the numbers 0 through 6. And here's the short list, which is just the even numbers 0 through 6. And I can include those in the same list and call and slice for them in whatever fashion that I want. But obviously, if you index for something outside, let's say that I called for the 5th element in the short list, there is no 5th element in the short list, right? So that's just going to kick an error. It does not assume any blank values here or anything. It only keeps the values of the list that you stored in it. Any questions on nested lists? Okay. Yeah.
I have a question about ranges. So
Yep.
If I just set a bunch of numbers together,
Yeah.
then it counts it as a range, and then it like reads back that it's a range in the variable. But then if I'm using the range function itself, I like try and take something out from the range, it just gives me an error saying that it's only It stores it as range rather than as like all the numbers in the column.
Correct. Yeah, that's really what a range data type is.
Okay, good.
It
That
is,
makes sense.
it is not the collection of numbers in that range. It is simply the fact that that range is there and it is those numbers that exist.
All right, that makes sense.
But if you want to have each of those numbers stored individually, you store them in a list, and you can just say list parenthesis, whatever range you want, and it'll automatically convert that for you. Okay, so some other stuff about strings, because I think strings are pretty important to be able to understand how to work with. Strings can be sliced too. So when you index a string, it's just going to look for whichever character number that is. So here you can see I have a string that's just called string cheese. And this slicing is going to look for all of the values from the 0 through the 6th index. And this statement is going to look for all of the values starting at 7 all the way through the end of the string. And so that first thing is just 0, 1, 2, 3, 4, 5, 6 string, right? It does not include the space. And then cheese is 7 through the end. Concatenation, very simply in Python, you can just use a plus operator. So here's 2 different strings. I want to make a third string that is a combination of them. I just say string 1 plus string 2. And then you can see how that would print there. Another fun thing to use with strings, I think, is when let's say I have a statement that I'm going to print out, but that statement is going to have numbers in it that are dependent on some other variables I have. So let's say that I have just stated however many cheeses that I have, and I've stated however many cheeses I want. And for whatever reason above in the rest of this function, these values can change. Maybe I'm asking the user, maybe it's dependent on the price of cheese, doesn't matter. But we know that these numbers can change, and then I want to put them into the same string. Well, I can have a base string, and then I can call the format method on it. And methods are basically a way that you can kind of play around with a lot of the data types that you have. There's a long list of them for strings that you can find, again, at this embedded link that will be in the slide deck. But dot format is just one that I think is very useful. And you can see here, I put in format x comma y, and that's going to replace the first set of brackets in this string with the first argument in this format, and the second set of brackets with the second argument, and so on and so forth. You could continue this for as many elements as you want. Any questions? Okay. This slide is pretty simple. I would hope that as engineers, we all kind of understand how math works in general, but just so that you can find and see where all of the operators look like in Python, this is what they are. So addition, subtraction, no different. Multiplication, division, exponent, a little bit different. It's just 2 multiplication signs right next to each other. The modulus operator, which just returns the remainder. So you can see in that example, 13 divided by 5 is not evenly divisible, but 13 divided by 5 is evenly divisible with 2 and remainder 3. What will be returned to you by the modulus operator is just the remainder. So it will just return 3 to you in that case. And then kind of the flip side of that is floor division, which is basically just what would the quotient have been without the remainder. So you can see again, 9 is not evenly divisible into 2. But when I call for the floor division of that, it will give me what it would be evenly divisible for, which would be 4, right? 2 into 8. Okay. And then just some other useful things to have. Again, these will be much more important when we're writing larger scripts and when we get into loops and those kinds of things. But these are assignment operators for if I just wanted to change the value of something at a consistent level. Possibly we'll see these being used in loops a lot. And basically it's just saying, instead of saying, I want to reassign A to be A plus B, in which case I would have written it, normally you would see A equals A plus B, right? It's taking whatever the previous value of A was, adding B, and giving that new value to A. In this case, you're just going to write it as A plus equals B, and it's going to do the same thing. And it really just saves you 2 quick strokes on a keyboard, basically. But there's something that's very common, and you'll see a lot. And they go for any of the mathematical operations. If you just put the math operation in front of the equal sign, it will perform that math operation on the variable that you're calling for with whatever is on the right of the equal sign. Any questions? Some more small useful functions that we have for getting input from the user. You can see it's just calling input, and then you'll see a string here, which is whatever the string is going to appear in the command window for the user. So when you see that, what the user would see is just string user sees. They would enter whatever value they want, and they would hit enter, and then whatever they put in is going to get stored in your variable var. Something that's useful to note about that is that the input statement will automatically assume whatever is being put is a string. So if I ask the user to put in their favorite number and they put in 7, what you're actually going to get out is the string form of 7, which if you guys play around with in Python, you could see that quotation mark 7 quotation mark is not the same as just 7. One of them is an integer, a number. One of them is a string. Same kind of stuff has been worked with in MATLAB, and hopefully you guys remember that. And then also length of a variable works for strings, lists. Just you want to find out however many elements are in your list or however many characters are in your string. You just call for the len parenthesis of it, and that will return whatever that integer is to you. Okay, conditional programming. So now we get into a little bit more if statements and stuff. And this is where I think you really start to see the basis of your codes being developed. So the if statement does not look any different, really. It's an if followed by a condition. And that condition could just be a true or false value, essentially. If I just wanted to type if, let's just say I had if condition, colon, just like that. But I had previously assigned condition to be a variable. Condition could have any value that it wanted other than false or 0, and this would still run. Python is going to recognize any value that you assign other than false or 0 as true when it comes to operating these conditions. So in that case, it would go through this, it would say, yep, okay, that condition is met. So it's going to run through task 1, run through task 2, and then it's going to go to the rest of the program. If condition was equal to false or 0, it would not complete task 1 or task 2, and it would just continue to the rest of the program. Python also has these operators which allow you to basically combine multiple if statements into a single line. So rather than maybe nesting them and having an if statement for condition 1, but I also wanted to check if a second if condition 2 was true as well, I could just in one line say if condition 1 and condition 2, then Python will check that both of those conditions are correct before performing the task nested within the if loop. There's also or, which will return true overall if one or more of the items that you listed or conditions that you listed are in fact true, and not, which will return true if the condition that it is preceding is false. So if I said if not condition, it would be checking to make sure that condition is false before running task 1 and task 2. Does everyone get that? Okay, and then something else very important for Python is the indentation, because indentation is how it recognizes. It does not, like MATLAB, have an end for your if or loops or anything like that. So everything is based off of indentation. Python will recognize everything in line with these tasks before it hits something that is dedented or unindented. It will recognize all of them as being within the if condition. So it's just something to pay attention to, because your indentation will tell how your code is going to run. Okay, so breaking down what some of those conditions could look like, right? Because a lot of the time, I'm not just going to be checking hey, if 7, right, I'm going to be checking, hey, if my variable is equal to 7, or if this variable is equal to whatever, then these are the operators that you're going to use. So in this case, equality, just checking to make sure that two things are equal to each other. You just use 2 equal signs. Non-equality, to make sure that things are not equal to each other, it's an exclamation point equal sign or a less than, greater than symbol together like that. There's also your greater than and less than, and greater than or equal, which is just a combination of a greater than sign and an equal sign, and the same thing for less than or equal. So those pretty simple, but that's how you can set up your conditions for your if statements to say if condition is equal to 7, or if it's not equal to 7, whatever your condition is. Okay, getting into loops. We have 2 main types of loops. We have for loops and while loops. For is going to be for iterating over a certain item. So that could be a range, it could be a list, or it could be a string. In this case, our string is ASME. When I say for X in ASME, it's going to assign X to be every value within this string. So it's first going to go through, assign it to A, and the tasks that I've assigned for this loop are simply to print the element. So it's first going to go in, the element is going to be equal to A, it's going to print that. That closes the first part of the loop. It then goes back in, says, okay, what's the second item? That's an S, it's going to print that, so on and so forth until it gets to the end of the loop. When it reaches the end of the E, it's just going to exit the loop, but there's nothing else for it to see. So that's all you get out of the response. Same thing pretty much for lists. I have a list here of even numbers 2 through 10. And when I say for I in my list, it's going to set I equal to, again, each of the elements starting at the beginning. It'll start with 2. And in this case, I just want to ask, what is the remainder, right? That's my modulus symbol. So I've assigned I being to 2. I'm looking for the remainder of 2 divided by 2, and that's going to be 0. And oh wait, these are all even numbers, and I'm dividing by 2, so the remainder is always 0. Crazy how that works. But you can see we'll have 5 outputs here because there's 5 different elements in the list, and that's going to be how long it takes to iterate through them. And then the same process pretty much works for ranges. You could say, here I have a range. It's starting at 1, it's going to 10, but it's counting by 2. So it's going to start with 1. Again, I is just going to be set equal to the elements in this range. The first one is going to be 1, and then it's going to go up to 3, 5, 7, and 9, right? Because when I count 2, 10, starting by 2, I only get to 9 because the next one would be 11, and that's outside of our range. So this would be the end of that loop. Any questions on our for loops? Okay, and again, indentation, very specific here. We need 1 indentation for these loops, and then everything with that level of indentation until it meets something that is unindented past that towards the same line where the for started is going to be considered for that loop. Yeah.
So there's no end, it's just when the indentation is done.
That is correct.
An indentation can be 2 spaces, 4 spaces, or it can have.
Yeah.
So I would recommend just using tab.
Tab is the easiest standard.
It's also generally the most IDs will automatically get for you as well. It's just make a tab as soon as you write for or if.
Okay, and then while loops, very similar, but instead of iterating over a certain element or number of elements, we're just going to meet a condition, and it's going to check that this condition is being met, and as long as it has, it's going to keep the loop going. So this is a very simple while loop. I did not include what the output here would be, but you guys could test it out. It's very simple. It's going to be numbers 0 through 9 because as you can see, I is initialized here at 0. So when this first starts up, it says while I is less than 10, well, I is 0, so 0 is less than 10. Yeah, that works. So it's going to go on and it's going to print that I, which is going to be 0. And then here's our assignment operator again, right? This is the same as I equals I plus 1. So this would be starting at 0. It's now going to be adding 1. Now I is equal to 1. That's the end of our indentation here. It's the end of our loop. We go back up to the beginning. Now I is equal to 1. 1 is still less than 10. Yep, keep going. And so it's going to keep doing that, keep adding 1 and printing out the element until you get to 10, right? Because then I is equal to 10. 10 is no longer less than 10. That condition has not been met, so it will not run through the loop at that point. And then here's an example of, this is why you might, this is why a lot of people I think prefer for loops over while loops, right? If this statement is not included, what happens to this? It just goes on forever, right? Because if I don't tell it to add 1 to I at the end of this loop, I is just going to stay 0 forever. And it's going to run through. It's going to say, yeah, it's 0 is less than 10, and it's going to print 0. And then it's not going to do anything else. And it's just going to go say, yeah, 0 is less than 10. It's going to keep doing it. So very important to remember that you have something like this that is going to change whatever your variable is here to end your condition at some point. Otherwise, it will just continue to run. And if you're not operating it in an IDE, someplace where you might be able to close it and debug it and stop running the script, it might just kind of like crash your computer. So don't do that. The lists here, again, why you might prefer a for in this situation. If I just had a for loop, I could set my variable I or X here to be each element in the list. And then if I wanted to do something with that element in this loop, which is, I think, a lot of the times why you have to loop through something, right? Let's say I have a large set of numbers and it's all temperature readings, but they're all in Celsius and I want to convert them to Fahrenheit. Well, maybe I'll go through and I'll loop through, and for each element, I'm going to take the element and multiply it by some number to convert it. If I do that, it's pretty easy in my for loop to just say, yeah, that's going to be I is my value. So I want to say I times this. And that's going to give the new value that I can store in a new list. If I'm doing a while loop, that condition really isn't in there. So instead, what you would kind of have to do to be a little funky with it is say, if I still want to mess with the elements of this list, then I actually have to include an indice of it, right? So in this case, I'm saying my count starts at 0. I'm going to run through this loop. 0 is less than the length of this list, right? There's 3 elements in this list. So it's going to run through this. I'm going to ask for whatever the element is and just print it. And so to do that, I call for the indexed value of count, which when it starts at 0 is going to be 0. So that's the 0 index element of my list, which is just so. And then I want to, this is another if statement that I included, just so you can see how if statements can be nested within loops. And you could see this is only going to register as a correct condition when the count is equal to the length of my list. So if the length of my list is 3 elements, then when count is 0, that's not going to be met. So it's not going to run through this task, and it's just going to add 1 to count, and then it's going to rerun through the loop. And again, instead of having I just set automatically equal to whatever the next element is in my list, I'm going to have to call for it from that index of count from my list. So it's just kind of a little workaround to get to what you would have with a for loop. But if you're doing it with a while loop, you just have to add a little bit more to it. And obviously, if you don't include this, your computer might crash. So for loops are just good to know that there's always going to be an end and it will exit. And if there are errors, then you can play around with it after. But it's really just kind of a personal choice thing and what you like. But you can see here for the output, I did ask for it when count is equal to the length of my list, AKA when I've reached the end of this loop. On the last iteration of this loop, I just wanted it to print count. So it's going to give me 2 because it's going to start at 0. It's going to get add 1 after it goes through the first element, go up to 2 after the second element. And yeah. Anything else? Cool. All right. So any questions overall for all the stuff that we've gone through today? Were you guys able to kind of work through some of the stuff on your computer and work through all of the examples that we have on the board? Okay. So one thing that we did not get any examples of is, oh, I'm up here. This is It'll be messy now. That is pretty much everything that we have planned to get through today. We're going to work on using all of these things to build some smaller scripts next week. And then the week after that, we're hopefully going to be including some of our modules to connect with Excel. And that will be the plan for that. Okay. Is anybody taking this for a class? Is there any reason anybody specifically wanted to learn Python? No?
One of our classes is probably gonna start using it,
Okay, what class is that?
space robotics.
Okay, cool.
My research professor uses Python, so I thought I might figure out how to use it myself.
Okay, awesome. What do they use it for? Do you know?
He uses it, it's Dr. Thomas. He uses it for a lot of stuff to run the observatory.
Oh yeah, a lot of like Arduino controls and things like that, right?
And then just other stuff for once we get the data, we do most of the data analysis in Python.
Yeah, okay, sweet. Yeah, so I think those are all pretty common applications. In industry, I've already talked with recruiters and, you know, people like to see that as just an additional skill set. I've used it in internships where I was told to go through a large material part list. I had like 2,000 materials and parts, and they were like, we want you to change all the values for these things in all of these 2,000 parts. And I said, I don't want to spend 2 hours doing that. So instead, I'm going to spend an hour and a half writing a Python script that's going to do it for me in 2 minutes. So I saved a whopping 28. But those kinds of things, I think you get more comfortable with it. You get to build some things faster. And then a big thing that we'll get into next week, right, is once you already have these functions built, I could have a function that's built for just extracting a table to Excel. And then I could include that function with any other script that I wanted so that I already have my data set and I just say, yep, I want to ship this out to Excel. I already have a function written for it. And so those kinds of things, once you get those already pre-built and you have them in your arsenal, they make a lot of things easier. But yeah, you can use it for controls, data analytics, lots of computations, matrix math, all that fun stuff. I used it to make a converter for my PDF of bank statements to make them into an Excel. Very, very fun stuff. But you know, it's a great tool to have. So at this point, you guys can be pretty much free to go. I'm going to run through a couple more examples of just inputting some items, making some variables, basically just making a small little calculator app, which you guys are welcome to stick around and watch. But if not, we'll be going through more functions next week and hopefully getting into working with Excel. Yeah. Yeah. So like, if I'm just like for writing this, I was doing a lot of just like those little test scripts and everything. If I know I'm just opening Python for like 5 minutes, I'm probably going to use Spider because it allows me to like, it's just what I'm comfortable with. And it allows me to see all of my variables very quickly, save the files to different places and things like that. PyCharm organizes all of your things into project folders. And then those project folders, you can set up a virtual environment for, which will have a different interpreter for different projects. So essentially, I'll talk again more about modules, right? I want to download an external module so Python can understand some extra functions, basically, that built-in Python doesn't have. I can make it so that just this project folder runs with these certain modules in PyCharm. And you can kind of do that in Spider, but you're typically just using like your base interpreter, and you can download more stuff on top of that. But if you have them all on top of each other, it can get a little jumbled. So PyCharm, just separating everything into projects, I think is very useful if you're building large projects. If you're just making small little scripts to like calculate some things or help you on your homework, that might be something I would use Spider for. So, but again, it's all personal preference. So I encourage you guys to like try out different ones and see what you like. Okay, cool. Thanks, guys. I'm just going to be making a calculator app up here if you guys are interested, but that's about it. I'm just doing this off the top of my head. So, we're just. Oh, actually, I kind of want one more thing from you guys. I want everyone. I just need to get everyone's email. So if everyone could just, I don't know what's the best way to do this. It'd be great if I had one.
I have one.
Could you get one out? Okay. You're gonna get out a piece of paper. If you guys could all just write down your email on it, and then I'll send out the slide decks to you guys so that everyone has those. And you can see all the links and everything that we had. I encourage you guys, if you're gonna just like start working out with stuff, the reason I made this slide deck like this was so that it's basically just like all of the functions that I commonly use. So you can just have that open, search for the functions, and hopefully the examples will show you how to do stuff. But again, if you ever have any other questions, Google is a great resource. Yeah.
Would you rather I just get over on my computer and they plug in their email and I send you that sheet, so you can just copy and paste it in email rather than writing that down?
Sure, if you prefer.
That'll be easier for you.
Thank you. Yeah. Okay. What's up? Yep, go for it. I have an error in my slide, apparently, so you're just gonna make.
Or at least
public fun of it.
in the hey, I asked you first. So, and I'm not sure, probably nobody knows. Is this gonna go from current slide? No, it's not. There we go. So in the basically your list while loop on the right, for one, the if statement is missing a colon, so that'll throw an error. But also, if anybody actually looks at this or tried to run it, you'd notice that this if statement will actually never print. This 2 will never print because we have while count less than the length of the list. So count equals the length of the list will never happen inside the while loop. So just a quick thing there to know what you're, yeah.
Maybe I'm just not thinking about it fully, but count is at max going to be 2, right?
Yeah.
But then the length of my list is 3.
Well, count is actually going to end up going to 3.
Start at 0.
Well, okay, yeah. And no, you're right. I wonder why that runs to,
I'm pretty sure.
because I ran this and it does
I
not
was just
print.
trying to logic my way through it, but my brain is kind of
I'm pretty sure length gives you the number of items in the list.
Yeah, it should be 3.
Whereas, like, which is obviously gonna be one more than the index
Yeah,
last value.
You should have been right. That's why I was running it. But it was not.
But anyways, in general, length gives you 3, I believe.
Yeah, length will give you 3,
But
but I don't know
if
whether,
you index for the last item, right, that's still 2.
but I did not run.
Did you have your count statement before the if statement?
No, I copied.
Can't get off that easy. Okay.
What's your email?
WIMARTI. That's it. That's me. Okay. So. Oopsies. Okay, so I'm honestly just kind of spitballing this, but we're gonna go through it and it's gonna work. So The first thing I'm going to ask is just going to be super basic. So we're going to have a list of operations for them. So let's say list ops. And we're going to say plus. And again, right, these are strings of all of these. So we're going to put quotation marks around them. You could do double quotation marks. I just prefer the single. Okay, we'll start with just those. So we first are going to give them this list. So what they're going to see is just to enter a number. Then they're going to see to enter an operation. Right, the code will pause and wait for them to enter this. But what's something I said about the input statement and what it's going to store that value as? Does anyone remember? It's going to store it as a string, right? So if I ask them for their first number, I actually want to get the number value for that. So I'm going to ask for the integer of it. But let's get even more specific, actually, because I want them to be able to put in decimals. So we're going to ask for a float. Then we're going to ask for them to choose an operation. And for this, it's going to be basic. We're going to have to know as a user that we have to enter in one of these as a string. And then we're going to ask them for the second number. And you see, I'm putting 2 spaces after these simply because when I run this, I like to be able to see that the cursor is a little bit over. Again, this is very like just personal kind of thing. But if I didn't put the spaces in, it would just be like right up next to the colon. So 3, I'm going to put in that, another 3, and it hasn't done anything, right? So next up, we're going to set up a loop that's basically going to, or not a loop, a set of if statements that's going to check whether which operation basically was chosen. And then based on that, it's going to apply that operation to the 2 numbers and print. So we're going to start off with our if, and we stored whatever operation they put in as OP, and we're going to check if that is equal to plus first. If it is, then we're just going to say the final num is going to be equal to the first one plus the second one. Now, something we did not include in the slide deck, but I will hopefully include in the later version of it, is this elif statement, which did not automatically align for me. So elif is, I think in MATLAB, it's just like else if, right? So it's rather than saying if else, it's giving you another condition. So in this case, we're going to say if it's OP is equal to a minus sign. And we're going to include another elif. And again, remember our indentation. So each of these elifs need to all be in the same line with the first if in order for them to all kind of register as the same statement. And then we're going to go through this. Now for this last one, actually, we're just going to say else, and we'll look into that in a second. Okay, let's see. Do we have any syntax errors? I don't think so. And then it's important, to just kind of think about where you want to put things, right? So I want to print the final number, and we're going to say print, we're going to give a general statement here, which is the answer is. And then we're going to use the format that we talked about, the format method. And we're going to call final. Right. And so if I wanted to just print the final num, right, I could have put a print final num in each of these elif statements. But for making our code look clean and just kind of standardizing it, it's better to evaluate what your final number is. And then we know we're going to print it no matter what it comes out to be. So we're going to print it down here outside of our if statements. So let's see if we made any mistakes. 7. Yep. Yep. So because it's looking for a float, I have to put in. Really? Oh, I'm just not typing. Sick. Nice. Okay. So there we go. We get 7 times 6. And because we are multiplying two floats, what your answer is going to be is automatically going to be a float. And so it's including a decimal point there for us. But so something else we can notice about this, right? If I run this and let's say I want to say 5, I'm what we could say is not a very inclined user who knows what they're doing. And I'm just going to put in a G here for my operation. And 2. What happened, right? The in our if else statements, we rather than having an elif that said if our operation is equal to division, evaluate it as division. So instead, we just had an else statement, which means that no matter what we enter in here, if it's not plus, minus, or multiplied by, it's going to divide the two numbers. I just kind of included that as a little thing to show because those are things that you might want to check. I think in the future and maybe in the next session, we'll talk about like checking inputs by users because maybe you'll want to have a condition to make sure, hey, if that person is going to try and put in a G, I don't want to let them. I'm going to keep asking them until they give me an actual operation or until they give me a number or until they give me what I want for the program to actually run. Because if I included an else statement or an elif statement that for division here, and then I put in a G, it's just basically going to quit out here and it's going to throw an error, right? Because it's going to not have a final number to print. So just things to consider, and we'll get into more of checking inputs and that kind of stuff in the next session, but that's all for tonight.
Does it save automatically?
Does it save automatically? Okay, PyCharm will automatically save, Spider will not. So Spider, save buttons up here, PyCharm auto saves, or there's also a Control S feature for like no reason, I guess, because it auto saves off any key that you hit. So. Yep. Gabby?
So my division is not working.
Did you use the other backslash?
So I'm curious to know if you're not the one. Or if I just get a typo. It's saying that it's not defined.
Is it not defined? You're good?
No, you'll get it.
Yeah, so I don't know.
I mean, the second number wasn't 0, right?
There should still be any.
Oh, I see, I see. What, do I need to operate this time?
Yeah, it gives us division by 0 here.
That's okay.